Welcome to Học Tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continuing with The Cat in the Box, today we read story number 43, From Firelight to Starlight. In 1802, the English scientist William Hyde Wollaston was studying the spectrum of sunlight passed through a glass prism to make a spectrum. He noticed that the colored patterns were broken up by dark bands, which he thought were simply gaps between the colors, so he did not follow up the discovery. But he did publish the news, and this roused the interest of a German physicist, Joseph von Fraunhofer, who investigated the phenomenon and made a much more detailed study of solar spectra in the second decade of the 19th century. Fraunhofer found that instead of a few dark bands, the spectrum was crossed by very many narrow black lines. Eventually, he identified 574 of these separate dark lines. Even more are known today, but all the dark lines in the solar spectrum are now known as Fraunhofer lines. A short section of the spectrum has lines packed together, giving an appearance superficially rather like the lines on a barcode. But what caused them? The answer, which would ultimately reveal what the sun and stars are made of, came from the work of Robert Bunsen and Gustav Kirchhoff in Germany in the 1850s and 1860s. This was the same Bunsen whose name is known from the famous burner, and the Bunsen burner was a key feature of the experiments he carried out with Kirchhoff. The fuel for the burner came from the gas that supplied households in Heidelberg at the time. This gas was derived from coal, and it could be combined with oxygen in a Bunsen burner to produce a clear flame. The flame could then be colored by adding traces of different substances. Chemists use this flame test to identify substances by the color they give to a flame. Sodium, for example, gives a flame a yellow color, while copper colors it blue. So when common salt is sprinkled on a flame and turns it yellow, we know sodium is present in the salt. Kirchhoff realized that it would be possible to make more detailed analysis using spectroscopy. So Bunsen and Kirchhoff built an apparatus that included a narrow slit for the light to pass through, a collimator to narrow the beam, a prism to spread the light out into a rainbow pattern, and an eyepiece, like that of a microscope, to view the spectrum. It was the first spectroscope. When the Heidelbergers analyzed the light from flames using spectroscopy, they found that each element, when hot, produced bright lines in the spectrum at precise wavelengths. In the yellow part of the spectrum for sodium, in the green-blue part of a spectrum for copper, and so on. One evening, they saw a fire raging in Mannheim, about 10 miles away, and from their laboratory in Heidelberg, they were able to use the spectroscope to analyze the light from the fire and identify lines produced by the presence of strontium and barium in the blaze. A few days later, Bunsen and Kirchhoff were taking a break from the lab with a walk along the Neckar River and discussing what they had seen in the fire. Kirchhoff rather later recalled that Bunsen said something along the lines of, "If we can determine the nature of substances burning in Mannheim, we should be able to do the same thing for the sun." But, he added, people would say we have gone mad to dream such a thing. Following the conversation by the river, they did indeed analyze the spectrum of the sun and found that many of the dark lines identified by Fraunhofer were in the same part of the spectrum at precisely the same wavelengths as the bright lines produced by various elements when heated in the lab. Kirchhoff soon explained what must be going on. These lines were dark because elements present in the outer layer of the sun are cooler than the layer below. As the light from the hotter layer passes through this cooler region, the elements absorbed light, removing it from the spectrum at specific wavelengths instead of adding bright lines to it. But the key point is that the lines are in the same places as the bright lines produced when the elements are hot, so the elements can be identified. Kirchhoff's discovery was presented at a meeting of the Prussian Academy of Sciences in Berlin on October 27, 1859. This is now regarded as the date on which the discipline of astrophysics was born, although that name was only coined in 1890. At that time, nobody knew how the lines were produced, but it didn't matter. Even without that understanding, by the 1860s, it was possible to find out what the sun was made of, and the same technique was soon applied to find out what the stars were made of. Good news today. In the vocabulary section, we only have a few. Spectrum of light. Spectrum of light. Roused the interest of somebody. Roused the interest. Solar spectra. Spectra, spectrum. Spectroscopy. Spectroscopy. Collimator. Collimator. Discipline of astrophysics. Discipline of astrophysics. The word discipline here is not the same as the usual meaning of discipline, like somebody is being disciplined. But here it describes a field of study, discipline of astrophysics. Thank you very much for your time. It has been wonderful. As usual, I will see you in the next story. Bye for now.